Okay, Assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself. My name is Muhammad Rafif. I'm from Trilogi University, majoring in Informatika Engineering. My names are 1810710. This is my presentation of my final thesis, which the title is Detection of Four-Wheel Vehicles that Get Pertalite Full Subsidies Using You Only Look Once version 3. First of all, I want to thank you to my two supervisor, Mr. Engineer Robullah, MCOM SNENG, Mr. Adesha Putra STM ENF Comtech MGMT. Okay. In this presentation, there's four will be split in four parts, which is introduction, research methodology, result and discussion, and the last one is conclusion and suggestion. So this is the introduction. Fuel. Fuel is one of the basic needs that are needed in the daily life of the Indonesian people in carrying out their activities, such as office workers who use private vehicles to work. Then also in agricultural sector where farmers use tractors to work their fields, and there are many more examples of the use of fuel, especially fuel oil. But there is a limited resource. On the other hand, oil reserves, especially in Indonesia, are getting thinner over time. This is exacerbated by the increasing domestic fuel consumption by Ali Akbar Vilayati 2022. Fuel consumption at the national level is increasing annually, which is based on data from the downstream oil and gas regulator based on BPH migas records. General type fuel consumption in 2016 had a total increase of 48 kiloliter to 55 kiloliter in 2017 by Maria Gabriel Wula 2019. Fuel subsidy. Fuel subsidy is a program from the government which is an old topic with always debated pros and cons that have been regulated in Presidential Regulation number 191 of 2014. Concerning the provision, so that the fuel subsidy program that has been regulated by the government is right on target to user consumers and also to increase the efficiency of using the state budget. Consumer criteria. According to Anugerah Stevenson Subsidies in Indonesia 2022, the fuel subsidy program provided by the government to the public has consumer criteria that are eligible for Pertalite fuel subsidies, namely privately owned four-wheel vehicles that have an engine specification size of 1,500 cc and below, which are limited to the use of subsidized fuel as much as 220 liters per day, while privately owned four-wheel vehicles that have an engine specification size greater than 1,500 cc will not receive subsidized fuel. YOLO V3 and OPENCV. From this problem, the purpose of the study was to apply computer vision, which will use the YOLO V3 method to detect car type object based on car shape patterns. YOLO V3 is the third generation of the YOLO, You Only Look Once algorithm series, and it's one of the deep learning methods that are widely used to detect objects. YOLO V3 has advantage over previous versions, namely height detection accuracy, being able to see object position more accurately, and object detection speeds by Huang et al. 2020, et al. 2020. Object detection, which is a fundamental problem in the field of computer vision, aim to improve computational models and techniques that are able to provide the most basic data needed by computer vision application, namely what objects are and where. Zhengxia Zhu 2019. Quoting from research, Muhammad Rafif 2017, object detection is the recognition of an object in an image and digital video that is processed using computer vision. A lot of research related to computer vision is deep learning. So the author created a program that can detect objects through image or photo input. The input needed is in the form of an image, which later the image is processed using the help of the OPENCV library and also the YOLO V3 method. The program is developed using the Python programming language. So also using the OPENCV library to process the input. Problem formulation. First, how to identify a vehicle object in an image or photo input. The second, how to determine the type of class of vehicle class. Limitation of the issue. The first one is the car data use consists of only two types of LCGC and LMPV cars. Second, the collected data only reaches 200 images, so the detection process carried out is a potential has a limit on the number of object detection. And the third detection is only through image, not through video. Research objectivities. Can identify the type of vehicle that deserve fuel subsidies. Can detect the type of car type. Get test output result from the detection of the type of vehicle that get fuel subsidies using OpenCV. This is the part, the research methodology part, which there's 5 steps of it, which the one is data collecting, labeling data, implementation of YOLO V3, the testing and evaluation. Data collecting. At this stage, data collection is carried out. The data collection is carried out in 2 ways, namely taking pictures and observation. The shooting process is obtained from various data sources. Then there is also a process of observing how to make a system in order to distinguish two types of four-wheeled vehicles that have been determined to get fuel subsidy in accordance with the provision of the system. Labeling data. Next step are labeling data. Labeling is carried out on its image. Data has been divided into 2 classes, must be done labeling, which aim to provide a bounding box or bounding box on each car image using label EMG software. YOLO V3 is a method that predicts objectivity scores in bounding box using a function, namely logistic regression. From this process, the expected output result is in the form of a file in the form of 4 coordinate points in each bounding box, namely Tx, which shows the coordinate of the point, x, Ti, which show the coordinates of the point y, then Tw as a measure of the width of the limiting contact, and Th as the height of the bounding box. YOLO V3 implementation. The method used in the study was You Only Look Once version 3, YOLO V3. You Only Look Once YOLO is an algorithm based on regression whose output from the process produces class prediction and bounding box on each object. YOLO was first introduced by Joseph Redmond Santos Divala, Ross Girsik Ali Farhadi on 2016 and is one of the deep learning methods widely used in the process of object detection. The YOLO V3 method implements a new network in the process, extracting a feature called Darknet 53. In addition to that, YOLO V3 is also able to detect an object in 3 different scales from Farhadi and Redmond 2018. The Darknet 53 network is an improvement over the previous YOLO version, namely YOLO V2 with the network called Darknet 19, Redmond and Farhadi 2017. This is the Darknet 53 architecture, which how to find the feature map, and there's 3 scale of the feature map 1, feature map 2, feature map 3. The thing to do is use the first process is going to the DBL process 1 time and residual time as 19 residual block nine process the residual block. After the DBL process we got the 19 residual block process, and then 4 time residual block, and then DBL 5 time, and then it will be saved to row 3 and do the DBL process 1 time and convolutional 2 dimension, and it will be resulting the feature map 1, which is 13 multiples 13 and multiples 255. So and in here is a height of the feature map, and and the second n is width from the feature maps. So the n multiples 3. 3 here is the scale of the feature maps, which are there are 3 feature maps, and 4 is the coordinate of the bounding box. 1 is the default uh, value, and C is the class here. And while I'm using 2 classes, C here is a will be filled in as 2. So this is the how the bounding box and the grid of the bounding box. The value of the TX, TY, TW, and TH are a value of network output from pre-processing, which is this is the TX, TY, TW, and TH. CX and CY are a coordinate value of the upper left corner inside the grid of the bounding box. So this is the position of the CX and the CY. PW and PH are a dimension anchor value in the grid. This is the one. PW and PH. Testing. Okay, next is this testing step. The testing stage is carried out by calculating the result of the mean average precision MAP or precision average result, calculating the error rate on or loss function, and carrying out the detection process using the data from the trained model. Mean average precision or MAP is the average of average precision or AP. To obtain the IP value, the intersection of union or IOU value need to be set to determine whether or not the object detection is valid to be performed. And this is the computational for finding the average precision. Next is the loss function, computational for searching the loss function. The first line is computational evaluation of bounding box, midpoint prediction, ground truth object prediction, and bounding box coordinates. The second one is a computational evaluation prediction with width and height bounding box with ground truth object area. The third line is computational evaluation of class values from predicted bounding box. The fourth line is computational evaluation of prediction of probability classes on detected object. Okay, we are moving to evaluation step. When there is a 3 step on evaluation, which are the first one is input new data, second is pre-processing new data, and the last one is detection output with showing the class of LCGC and LMPV. This is the result and discussion step part, where there's a data splitting step. Well, on this thesis, I'm finding I have a 200 total data of the image, the card image, which I'm splitting it into 3 type of data, which there is train, validation, and test. The percentage of the splitting is train have a 70%, validation have 20%, and test have 10%. The total of the train, validation, test is carried out 140, 40, and 20. So all of the total is 200 data images. So we're going to move into the YOLO V3 implementation, and this is the training process. The first thing we are going to do is unzipping the data. After that, do some cloning the darknet from the GitHub repository darknet that were used for building process and training from YOLO V3. After that, there's GPU activation, which for activating the GPU and building the darknet. Next is uploading YOLO V3 configuration and OBJ names and OBJ data. Is copying and uploading configuration YOLO V3 that were used to customize the classes, filter, and batches from the training. After that, we're going to make some backup from OBJ data and OBJ names. Next, uploading darknet file, which is upload pre-trained convolutional layer weights, is uploading darknet v3 .NET 53 file, which included a detector process from YOLO V3. After we uploading the .NET file, we're going to start the training using this .NET detector train, content data, object data, content, and passing it into the content.NET configuration YOLO V3 custom CFD. After that, passing it again, content.NET 53 convolutional 74, and this is the content drive, my drive, YOLO Skripsi, and train log is the training log history to save the training log history. This is the MAP chart visualization source code. So this is the source code for visualization, visualizing the mean average precision charts with using import CV2 and import matplotlib pyplot as PLT. And after this, all this function running, emshow here is going to is a function for showing the chart PNG, and this is the chart of the MAP visualization, where there's MAP, here it is, visualization MAP chart, where there's the mean average precision accuracy, will get the score of 75%, and the iteration is using the 3000 iteration, approximate time left 0.02 hours, and average loss scores is 0.05%. And next is the result of the testing from the training, which both of these pictures are a car with LCGC class type, and the classes were correctly shown and detected, and the accuracy is 1.00, which if we change it into percentage scores, it will be 100%, and this is to 100%. And the next is the type of a car, type of a LMPV class car, which the class is showing correctly and detected correctly, and the accuracy was 1.00, which is 100% too, and LMPV in here to 100%. Evaluation. This is the source code of evaluation detection process from the program that I'm making. First one is import CV2 and import numpy as an NP from google.colab.pages import CV2. I'm sure for showing the image. The first one, in here, the first step we're going to do is load YOLO algorithm net equals CV2 dnn.readnet with the YOLO V3 custom final weights and YOLO V3 custom configuration, and load the all object classes, which I'm using two classes. There are LMPV and LCGC that will be fitting into this classes variable. After fitting into the class variable, we're going to find defining layer names, which from these classes to and then loading the image CV2. I'm read test for GPG is a image that we're going to detect, use for evaluation process. Height width channels equals emg.set. After uploading the image, we are going to extracting the filters to detect the object using the function blob cv2.dnn blob from image, where was a function for extracting for extracting the score of the height width channels emg shape, and passing it into the next source code and passing it to the outs equal net forward and output layers to get the result of the output layers. Okay. This is the class ID confidence boxes is display information on the screen from the image that we are going to detect it using function for output in out and function for detection in output. Detecting this is and the next step is detecting confidence in 3 steps. First of all, there's a scores variable class underscore ID and confidence. How to detect the confidence? Where the first step is obtaining the detection score and put it into the variable scores. Secondly, obtaining the highest score from the result and will be fitting into the class ID. The third step is obtaining the confidence value and will be confident value from the score on every array on the class ID. Sorry. Okay. Function if confidence bigger than 0.5 is a condition. Means if the object is detected, it will get the center X scores and center Y scores, the width scores and edge scores. After that, there's drawing a rectangle X, Y boxes pen on which these were used for drawing the bounding box. Confidence pen is for showing the confidence value and class ID for showing the classes. Next is the removing the double boxes using the non-maxima suppression. Indexes equals cv2.dnn and non-maxima suppression boxes were used for erasing the double boxes that are going to show which boxes. There are 2 boxes, which is grid of the bounding box and the bounding box. It's going to make we will have to erase the grid of the bounding box using this non-maxima suppression, which there is x, y, w, h is the coordinate for the bounding box. Label equal classes for showing the classes and confidence for showing the confidence value. And then CV2 rectangle EMG is for drawing the bounding box on the image, and CV2 put text emg.label for showing and put some text on the image, which there's a label of the classes and the confidence value. CV2 unshow is for showing the image and the image result from the detection process, and CV2 wait key is for closing the tab. Next are the result from the evaluation process. This is the result from the evaluation process, which are much a little bit different from the training. Which this both of these cars is a type of car, type of LCGC car, which the class were showing correctly from the detection result, and the accuracy is 1.0, 1.0, and 0.199. Which if this one will be changed into percentage scores, it will be 100%, and this is going to be the 99%. Second is the both of this picture is a picture of the 2 LMPV type of class car, which same as the LCGC, the classes were showing correctly, detected correctly, and the accuracy of these two pictures that has been detected was 1.0 and 1.0, which means it's 100% accuracy. Conclusion and suggestion. Conclusion. Based on the result of research that has been carried out on how to detect the type of car type based on the pattern using the yellow filtering method, the following conclusion can be drawn with point 1. The result of the mean average precision value obtained from the training process reached 75%, and the loss value obtained on was 0.5%. The number of steps used during the training process is 3,000 steps. Point 2, the detection result in the testing process using test data get an accuracy value of 100%. This testing process used test data in the form of image. Point 3, the result obtained in the detection process using new data at the evaluation stage showed good result in the LMBV class with an accuracy of up to 100%. Point 4, the result obtained in the detection process using new data at the evaluation stage showed good result in the LCGC class with the highest accuracy, namely 100%. And the last part is the suggestion. Based on the result of the research, there has been carried out. Researchers have several suggestions for further development, among others. Point 1, the data taken in the study only use images, so there are still shortcomings in the car detection process. In the next development, the data retrieval process can use video so that the model is able to detect car patterns to make it much better. In the next study, it is hoped that the number of class of car types can be added more back so that the models can recognize more types of the cars. Third, point 3, in the next study, it is expected that there will be an increase in the amount of data. In this study, the amount of data was only 200 data. So there needs to be an increase in the amount of data so that the limit on the number of the detection can be increased. That's all from my presentation of my final thesis. For every shortcoming, I apologize. Thank you for listening and watching. Wassalamualaikum warahmatullahi wabarakatuh.